Let's see. So this one is number 5 on the worksheet. And it just says lithium reacts spontaneously with bromine to produce lithium bromide. If 10.0 grams of lithium and 110.0 grams of bromine react, determine the following. And don't forget that bromine is diatomic, right? So I think we did this. I think there's 4 steps in this thing or something like that. So we'll make sure we got that going on. So step 1, of course, we got to know what the balance equation is, right, Mr. Wing?
Yep.
That's right. So let's go ahead and show the equation. You see that, so it's lithium plus bromine. Notice it's diatomic, and then it yields lithium bromide, right? So we got to make sure that we're, why is it just LIBR? Why isn't LIBR2, right? Why is that?
Lithium's a +1 charge, and bromine's a -1 charge, so they cancel out.
That's right. Okay, does that look balanced? That
Yeah.
looks balanced to me. Okay, so what's up, Bill? What do you think? Balanced?
No.
No. So let's go ahead and balance that thing right there. Does that look balanced now?
Yes.
It looks good. Okay, so what we got to read this as is for every 2 moles of lithium, we're going to react it with 1 mole of diatomic bromine, and we should produce 2 moles of lithium bromide. So that's the first step. You always got to balance the equation, make sure it's balanced. Otherwise, it's not going to work out, right? So that's question 1, I believe, on that number 5 worksheet, or A maybe or something. If we go to the second thing, we got to find the limiting reactant, okay? This is the part that a lot of people have trouble with, is finding that limiting reactant. All you're going to do is you're going to find the moles of each reactant, and then you're going to divide each of those moles by their coefficient. So I have that step 1 and 2. So this is a 2-step problem here. So how do we find the moles of our reactants if we are given grams? How do we find moles?
Divide by molar mass.
We're going to divide by molar mass. Okay, so I'm going to do that for both reactants here. We had 10 grams of lithium, and the molar mass of lithium is 7. It gives us 1.43 moles of lithium. And then we had 110 grams of bromine, and we divide it by its molar mass, which is 160. Notice we did include, there were 2 bromines in there, not just 1, because you do include the subscripts in the molar mass, but don't include the coefficient, all right? So it gives us 0.688 moles of bromine. That's step 1. All right, now what do we do next to figure out which one's the limiting reactant?
Divide by the coefficient.
That's right, we divide by the coefficient. So we're gonna divide by each of their coefficients, and you see this right here. So we take the moles of lithium and divide by 2, because it's got a 2 up there as a coefficient, and we take the 0.688 moles of bromine and divide by 1, because it has a coefficient of 1. All right, what do you think? Is that pretty good?
Mm-hmm.
All right, everybody understand so far?
We're good.
All right, so you just find the moles and then divide by the lowest, or the coefficient. Now the lowest one is our limiting reactant. It's the only one we give a crap about, right? So let's see, which one is the lower one of the 2 at the bottom between after we divide by coefficients? Is it the bromine or the lithium? Looks
The
like
bromine.
It's the bromine. So I'm gonna go ahead and circle that, and that is our limiting reactant. So that's gonna determine how much lithium bromide we're gonna actually produce. That's how we're gonna do. So that's how you do step 2, is to find the limiting reactant. You find the moles, and then you divide each of them by their coefficients. Whichever one is smaller, that's your limiting reactant, okay? So then number 3 comes up next. I went ahead and told the original moles of each one. Now that's something I want to point out to everybody. Don't use these moles down here, that 0.715 and that 0.68 here. You want to use the original moles that we had right here, the 1.43 and the 0.688. Now, we don't even care about the 1.43 because it's in excess. We only care about the 0.688 right here. So now the third question says to determine the mass of lithium bromide theoretically produced. Now, another way that might be worded might be something like determine the mass of lithium bromide expected. It's the same thing. So now what we're going to do here, do you guys see how we got the moles of our limiting reactant bromine? Now we can use what we call the fog machine, right? Find over given. So if you look at lithium bromide, it has a coefficient of 2, and bromine has a coefficient of 1. So we're going to take our moles of our limiting reactant here, and we're going to multiply it by 2 over 1. Find over given, fog machine. And that gives us 1.38 moles of lithium bromide that is expected. And that gives us moles. Does that sound pretty good? Mr. Wing, you doing all right? Ms. Beers, everything sound pretty good?
Yep.
All right, all right. So that's our moles of lithium bromide. If that's all they wanted, then we'd be done. But the problem is they say determine the mass of lithium bromide. And Mr. Wing, how do we get from moles to mass of lithium bromide?
We need to multiply by the molar mass of lithium bromide.
That's right. And lithium, remember, has a 7, and bromine has an 8, which gives us a molar mass of 87 grams per mole. So if we take these moles of lithium bromide, 1.38, and multiply it by 87, we will get the mass of lithium bromide that's expected. All right. So really, it's a 3-step problem to kind of determine how much product is going to be expected. You just have to find the moles of, you have to balance the equation, and then find the moles of each reactant, determine which one's a limiting reactant, and then do the fog machine and get us where we need to be. All right. And I think there's one more question on here, right? Let's see. Before we move on, actually, does anybody have any questions so far? Let me put it up here, see if anybody's got anything. Everybody good so far?
We're
Man,
good.
it's easy to teach smart kids. We got it made. Let's see. Okay, so let's go to the next thing here, which is what is the percent yield of the reaction? So you just got to think about percent yield as kind of like if you expected $100 from me and I gave you 80, you only got 80% of what you were supposed to get. So that's all this really is. And this is asking for what's the percent yield of the reaction if 113 grams of lithium bromide was isolated in the lab. So imagine we actually did a lab on this and you only got 113 grams. Well, we learned from the stoichiometry, it always tells us the expected amount, which is 121 grams. And you always take your observed, which is 113, which we isolate in the lab, and we divide by 121. And then we just multiply by 100 to get to a percent, which is about 93.4%. And that is how the yield works. Mr. Wing, if that is the percent yield, what would be the percent error?
To find the percent error, you're just going to take 100 minus 93.4 because they're the opposite of each other.
That's right. So about 6.6% error, is that right?
Yep.
So that's so just know if you had 100% error, that would have been perfect, and that's what we've got. Okay. So I think that's it. I think that's the only thing we got. Does anybody have any questions over that, or do you need any other questions answered?